Hello everyone and welcome to the first OpenGL series. Here we're gonna cover the OpenGL static pipeline using C# and Tau framework. Okay, so before I start working with you and showing you how to create OpenGL application, let us first see the resources which we can get the knowledge from. First, you have the OpenGL Super Bible, the Blue Book. It's very great book. Right now, the latest edition was the 5th edition released, and it covers the shader pipeline, and it is really great book. Now, although I have some certain, like, how can I say, criticizing a little bit. I have some critiques around it because the problem is it hides from the user a lot of stuff, like almost like until 75% of the book, and then it exposes the user to the details for the rest of 25% of the book, which I really personally I don't like, but probably it's very good for other people. So basically it is really basically it is really good book covering the programmable pipeline, okay, with just shaders pipeline. Fixed function pipeline, OpenGL is the or the static pipeline is a way of programming OpenGL applications without utilizing shaders. So you don't configure, or you don't actually have a full control over how your objects are being rendered. And we're gonna see probably later in the middle of the video series how different when you are not using shaders and when you are using shaders. Probably by the end of the series, probably I'm gonna show you like an introduction, or show you how to make one simple shading pipeline using the OpenGL application, using the shading pipeline, just as a reference or as a tutorial, rather than just simply the thing that you have to include in your seminar work. So basically, in your seminars and your applications, just feel free to use the fixed function pipeline. There's no pressure. There's no need to do the shaders or using OpenGL shader pipeline unless you wanted to. So it's up to you. But basically, in these lessons, we're going to cover only the fixed function pipeline. Up to the next book. So we have here the OpenGL programming guide. Um, Actually, it's the latest edition was the 7th. Probably I clicked wrong on Google and I forgot like to have a look at it. But anyway, the latest edition is the 7th edition. It is really as well a good book. Both of them, they come together. Yeah, usually most of people who are working with OpenGL, they have like this book and another one which you're gonna see right now, which is the shading language for people who would like to write shaders. Okay. Um, this book covers the same content, almost the same content as the Super Bible, but in a different way, different examples. So it's always nice to see how different authors look at a certain function, and they implement and they give up an example differently, so you can see how certain functionalities of OpenGL could be utilized. It could inspire you to do something really as well great. All right. For the shading language, OpenGL shading language, the latest edition was the 3rd edition, and it is really great book about shaders. If you would like to work with shading pipeline, working with shaders, making your own. How can I say, rendering your own. Making your own renderers, like customizing how objects will be rendered in your scene. Would you like to have caustics, for example, how, for example, light refracts out of a glass, or for example, you can even write a shader, for example, as you can see here. There's on an elephant, there's a Julia set fractals, so you can even have some sort of dynamic part where it comes to texturing and materials. You can represent metals really correctly, you can represent plastics really correctly, and so on and so forth. You have a full control over how your materials and how your objects look like. Okay, so it's up to your imagination right now. The latest book, finally, which I could recommend to you if you would like to have it. Most, not all of people like it. I had it when I was a student, and it is a great book for if you would like to learn really computer graphics, but to have more how to do some certain implementation part in OpenGL. And they use the static function pipeline. So this is They could be handy for you if you would like, for example, I would like to draw curves, for instance, and you really don't know how to draw a curve. In this book, it will describe you what curves are, how they look like, and then they give you even the probably a fraction there, or just a code snippet how to implement these curves. Okay, so it's really a very very interesting book. All right, so right now we have all the books in hand which we're gonna cover. By the way, for since we are working with functional pipeline, fixed function pipeline, we are not gonna. I mean, fifth edition is the latest one, but basically we are going to work with OpenGL 1.5 specifications. So you could find the OpenGL Super Bible second edition, which has already all the functions for 1.5 OpenGL specifications. Okay. All right. Now let's go on to tutorials. Swiftless tutorials are really great. They are covering OpenGL. Right now he's covering actually OpenGL 4.0 specifications, the latest one, and he's having a really nice series of tutorials. And this is shading pipeline. As well WebGL. By the way, WebGL is matching OpenGL ES 2.0 specifications, so it's based on that. So you can have actually a real OpenGL application rendered in your browser, but of course you have to have either the latest Internet Explorer or latest Chrome or latest Firefox for that. To be honest, I don't know about Safari, so basically I know for these three browsers for sure they are capable of rendering OpenGL scenes into the browser. All right, moving forward, this is for the tutorials over here. NIHI tutorials are the most famous tutorials for OpenGL. Although they are completely outdated right now, nobody is actually looking at them because you're not using the shading pipeline anymore, or they never had. Right now, they probably started working on it as this date of recording, but of course there are a lot of lessons and tutorials how to implement certain things using OpenGL, fixed function pipeline. And as you can see here, I mean, moving bitmaps, blending, for example, for transparency, texturing, and lighting, and other stuff. In this series of tutorial, they actually covered, and there are really quite interesting series. So I advise you to have a look at it just for fun, see what the code is, what kind of code they offer. Probably you can grab some pieces of code from there and just include it in your application. Another website for resources is the OpenGL/wiki/code resources, and in here you get like the list of a lot of tutorials over the internet, how to do or how to implement certain tasks in OpenGL, or generally introductory tutorials to OpenGL. Okay. Going further, Lighthouse 3D as well. They are really great. To specific tutorials, how to, for example, as you can see here, shading language. So how to use shading languages if you would like to include shaders in your application. Of course, you're gonna use C++ there. So basically, just for you to know. Yeah, and programming examples and such. So this is a really good website over here. Now up to the frameworks which we're gonna use right now. So basically we're gonna use the Tau framework, and Tau framework is just a wrapper, .NET wrapper for OpenGL applications. Basically, when you write OpenGL application, you write it in C++. But in order to write it in another language, you have to have some sort of a wrapper which will call OpenGL function calls from the GL/DLL library, and get it through your language, which for example right now is C#. There's as well Java wrappers out there for OpenGL, and you can actually get these functions and call them from your C# code, as we're gonna see. Now there are this project, Tau project, has been stopped since like 2005, and you can download it right from there. Unfortunately, there are two libraries which I believe they were compromised in the meantime. I didn't know that they have been changed, but they were for sure have been changed, but probably they haven't notified. in here, or they haven't notified it in DSVM probably, or probably I missed it somewhere. So I'm gonna give you these two DLLs over the forums. Okay, so in order for your applications to start working correctly. Um, Now, the project which is going still is the OpenTK, which is as well C# library wrapper for OpenGL. Unfortunately, I well, I actually really don't like it because how the code looks like. I mean, for example, for Tau framework, when you look at the code there is almost matching the C++ code. So if you open a book, for example, the Superply 1.5, if you look at the function, you can actually grab the exact same function calls, put them in your OpenGL application, and just with a very tiny modifications, you can actually make these functions work. So, for example, if you have a GL translate function, for example, for moving an object from one position to another, you just simply type gl.gl translate. But here in OpenTK, they're a little bit different, if you know what I'm talking about. So basically, they're uh, the code is much more. Even after they made the wrapper, they made some sort of a beauty kind of overlay over it. So people like who are not so right now you cannot actually even it will be difficult for you to follow some certain books like the books which I already mentioned over here. Okay, but it is actually following the shader pipeline right now. As far as I remember, this the latest edition was the for the 3.3 OpenGL specification, so it supports shaders. That's for sure. Okay, that's in case if you'd like to stick with C# and OpenGL. All right. Um, One more thing I would like to show you is the shader pipeline here. I have over here in my clipboard a WebGL water which created using the shading pipeline, and as you can see here, these stuff are really almost impossible to achieve, like, or probably it could be achieved, but it would be really difficult to impossible if you would like to implement this using the static pipeline, which we're going to learn today, but or during this course. But generally, I don't know if I can move it. I don't know how the recording speed is gonna be, but I'm actually trying to. Yeah, apparently the recorder doesn't allow me to touch the water or to interact with the application. But anyway, this is a real-time OpenGL application that really runs on in my browser. You can grab this URL and test it for yourself. It's really beautiful demo. And it utilizes and shows the ray tracing, reflections, ambient occlusion, and dynamic shadows and other stuff. It's really great example of OpenGL shading pipeline. Really nice example. Just have a look at it and have fun, just interacting with the application. And I'm gonna middle click on that one. And okay, and let's go back to Visual Studio. So we already know our resources which we're gonna work with. Now we're gonna start working with OpenGL. So basically, I'm gonna create a new project, and let me erase this. So I'm gonna be in the projects folder. This is gonna be OpenGL app, and it's gonna be Windows Forms application, and we're gonna hit OK. Now, the first thing when we start working, there are a couple things we have to do. First of all, I'm expecting from you that you already read the documents like OpenGL overview PDF. You have the matrices and vectors, vectors, and OpenGL transformations, viewport and projection document. These four documents are very important that you read before you start launching, or before you actually start watching this video. So please make sure that you have read those documents before, because I'm relying that you already know the content of this document. Okay. Now, if you look at the workflow of a very simple OpenGL application, first thing you have to do is to create a window. If you are using glut libraries, for example, you could just simply create a window from there. using glut, I don't know, dot create window, and then you pass the window name. If you are working, for example, with C++ and without glut, you could have probably have to write a huge like API call just in order to create a window. Or people usually use Qt, for example, or GTK or SDL in order to create windows. So basically, we are using C# here to create .NET Framework to create our windows. So this is our first step. The second step is initialize OpenGL, our OpenGL context. Now, if you look over here, we have our window ready. Now we have to initialize OpenGL. Now, first thing you have to understand is OpenGL is an API. It doesn't understand anything. It doesn't give you anything to draw with. You just simply have to work. I mean, it doesn't give you any drawing surfaces. You have really to specify the drawing surface, and then OpenGL will project these things on your screen, okay, or render them on your screen. But the rest, you have to handle everything from drawing to rendering to handling I mean Windows events. Loading 3D objects is your job. OpenGL doesn't understand any of those. You have really to program to write a library to, for example, to load 3D objects. OpenGL doesn't understand images. You have to actually write your own libraries and your application in order to load images into OpenGL. So you have really to understand that very carefully. So basically, we have to initialize OpenGL. Now, in order to initialize it, TAL Framework gave us one control called the simple OpenGL control. And in order to add it, I'm gonna right click over here. First of all, I would like to be organized, so I'm gonna hit add tab, and here I'm gonna write OpenGL. Yeah, and this is it. And right click as well again, and then I'm gonna choose items. This way, which I'm showing to you right now, is the same way where you can, for example, add any control, not only this OpenGL control, but any control that you get from the internet or you make on your own, or somebody made it for you and then you import it. Okay, so this is the same workflow. And probably, okay, there you go. I'm gonna hit browse, and I'm gonna go upstairs into projects. Now I have dependencies folder over here. Now, to be honest with you, I'm gonna cut that folder, put it inside the OpenGL app, inside here, okay, because I had it already prepared, and you're gonna have this folder already uploaded on DLMS. Don't worry about that. Now, these are the two libraries which I believe the people from TAL Framework, they probably changed some stuff. So I'm using the ones pre modifications, so before the modifications. Okay, so basically you have to pick up the tau.platform.windows.dll. So you have to pick that one. So hit open. And by default, it has to be checked. If it is not, please check it. So simple OpenGL control, it has to be checked. And hit OK. And I'm going to drag this control over this form. Now, a couple of stuff I would like to do here. First of all, I'm going to rename this control, this form, in fact, into frm OpenGL main. There you go. And yes. And I'm gonna grab F4 here. I'm gonna grab the simple OpenGL control, rename it to OpenGL control. It is easier to access from code. And since this is where the drawing will happen, I will just simply, because it's quite tiny area, I'm gonna increase it, oops, to be, in the docking, I'm gonna make it fill. Okay, and the form title, I'm gonna give it, where's the form title? Text. Okay, I haven't chosen there you go, text, and then I'm gonna have OpenGL window. Okay, so we have got our OpenGL window ready. One more thing we have to do is okay, so basically we haven't initialized even the control, by the way. We just put it there. We haven't initialized it then. And as you can see here, start main loop. So basically you have, this is where in programming, like infinite loops are really useful. I know that usually guys always you avoid them, but in computer graphics, infinite loops are the only ones which we use in order for uh, to work, in order for our game or our application to just work until we actually interrupt the application by just hitting certain keys or close the application. Then the main loop will close or will be done. So basically, we need a timer, okay? Because if you are animating something, then you have to animate over time. If you are moving, if you are actually as a person moving from one place to another, you are moving in 3D space, and as well it takes you time to move from that point to the other point. So basically, we need a time here. We need some sort of a clock that will just simply refresh and render our scene every certain amount of time. So basically, I'm gonna include a timer. So in the components tab, you have a timer control, and there you go. And this timer control is one of the controls which are called the tray controls, which they don't show up in your windows, but they are in fact just sit in your tray. But of course you can reutilize them and you can see their effect in your application. Now most of people forget to enable this because by default the timers are disabled. And the interval, I'm gonna say for every millisecond please redraw the screen. And here I'm gonna call the T main loop. This is for the name of the control, and there is only one single event in there, by the way. It is on ticking. So for every ticking, when the clock just ticks, then we're gonna just simply call the rendering of the scene. So I'm gonna double click over here, and right now, most probably, I mean, I will not see anymore this window, so we will not need it anymore. We'll just simply see it in the runtime. Otherwise, we don't need it right now. So let's get on to our PDF over here. So first of all, we created the window. Second, we have to initialize our OpenGL. So in order to initialize our context, after initializing components, you have to write this.opengl control dot, well, actually the OpenGL control, the control name, so simple OpenGL control name. And here you type initialize contexts, because if I comment this, if I hit Control F5, I get this error. So no device or rendering context available, and when you see the screen, it is completely white. So we have to uncomment this, Control F5. As you can see here, I got my OpenGL black screen over here. Okay, this is the first thing. Now the second thing, starting the main loop, and inside the main loop we're gonna do the following. We're gonna clear the frame buffer. In our case, I'm just interested in the depth buffer, and I'm interested with the in the color buffer. Okay, so in order to be organized, I'm gonna just simply separate this into a function called render scene. So void render scene, and in here I'm gonna start clearing my buffer. So before I do that, I forgot to implement or to import one more library. So in the reference tab, right click, add a reference, and I'm gonna browse, going to my OpenGL app. In the dependencies folder, I'm gonna grab the tau OpenGL DLL and hit open, and hit add and close. Now of course automatically you have to add here into the using, so using tau.opengl, and of course here we're gonna make our OpenGL call. So gl clear, and in here I'm gonna add gl.gl underscore color underscore buffer bit and the bitwise OR, and gl.gl underscore depth underscore buffer bit. So right now I am clearing the color buffer and the depth buffer in my video card's memory. Now upcoming next, we have to reset our model view matrix, and you know that already. I have covered that in the document of transformations, I believe, or probably it's here. Have I covered it here? No, then it's on the other document, the transformations and projections. So I've covered why we have to reset the model view matrix. Please refer to that document in case that you forgot. Now here I'm gonna just say GL. Now OpenGL is a state machine, and you have really to specify which matrix you are going to work with, because there are a lot of matrices in OpenGL. So model view matrix is the matrix which is responsible for positioning our objects, or you can say like well, it saves the positions of our objects in our scene. Okay, this is all the information of our objects positions is actually stored in there. So basically GL matrix mode, I have to specify which matrix I'm gonna work with, and I'm gonna tell OpenGL, okay, please, I'm gonna work with GL model view, and gl.gl load identity. So right now I'm resetting my model view matrix, and then afterwards, after resetting my model view matrix, I have to draw my object. So fine, I'm gonna go here, and in order to draw an object, I'm gonna call gl begin, gl underscore. For now, I'm gonna draw the first small triangle, gl triangles, actually triangles. There you go. And always surrounded by immediately by GL end, so you won't forget this one. Sometimes I forget it and then I get a blank screen and I cannot remember why, because I usually forgot this one. So please do not forget to write it right there. Now, and here I'm gonna say gl.gl vertex 2D for now. I'm gonna just simply punch in 2D numbers, -1 for x, and comma, and 0 for y, and I'm gonna copy this, paste it several times over here. Let me just make some space, and for x is gonna be 0, y is gonna be 1. For the last point in the triangle is gonna be 1 for x and 0 for y. Okay, and let me see here. You call flush. Sometimes you don't need to, sometimes you would like to, but generally you force OpenGL to send everything from your client, because it's more having like a working with OpenGL is more like a client-server kind of relationship. So your code, you are as a PC, I mean you are as a programmer interfacing with the server. So for example, you tell OpenGL, okay, flush everything, I mean push everything to the video card, force it to be rendered, and I have done everything in terms of drawing. So this is what you tell basically OpenGL with when you say GL flush. Okay. Now swap buffers is already has been handled for you when we actually call it here. If you would like to, you can call, as far as I remember, it was here somewhere. If it is not, then it's okay. Swap buffers. As you can see here, there's the way of how to swap buffers. So basically, you have the first frame is being rendered. While it is being rendered, there's another frame behind, sitting behind, it's just simply being prepared. Once the first frame has been just displayed on the screen, immediately the computer or OpenGL swaps the buffers, so it immediately shows you the second image with the second, I mean, frame. But of course you don't feel that, because this happens really quite fast, unless you have, for example, some really complicated application, and of course you're going to lose the frames per second, because usually it takes time for OpenGL or any rendering engine or whatever, I mean whatever API or card, actually it takes some time. The graphic card takes some time to render some certain scenes. So that's why if you have swap buffers, if you feel that the application is slow, this is because your video card needs time to prepare one image and then show it to you, and then until it is being shown, another image is being actually in the works and behind, so it will be swapped. So basically we will not use this one for now, because I'm having this one is handling it for me. So in here, for every millisecond, I'm gonna say render scene, and this dot OpenGL control dot refresh. Okay. Now let's see how this application look like. So basically, here's our window, and if we stretch this window, as you can see here, we got really bad, like kind of, it's not okay because our application is not working properly. So we have to fix how our object is being rendered over here. So I'm gonna leave this right as it is. I'm gonna add one more class. Okay, add class, and I'm gonna call it GL settings. And in here there are two functions I need to set up here. So public static void set attributes, and another one, public static void correct view, and it's gonna take the int width and int height. Now what I wanted to do here, let me hit Control 5 again, is tell the OpenGL application that whenever the window is being resized, please correct the view according to the size of the screen. So in case if I had a 4:3 aspect ratio monitor, I'm gonna have my object displayed properly. If I take the same application and put it on a wide screen, 16:9, 21 to whatever number, then my objects will not be stretched from the sides. It will be rendered even as well normally. So this is what I'm trying to hunt here for. So let's first set correcting our views. So basically, I'm gonna specify. Of course, I have to hit here the using. So using tau.opengl, and in here, I'm gonna just say gl.gl viewport. Now, a viewport is the window to our world. Okay, so basically, if you are in a room, okay, and you have a window in that room, and then outside you have a huge world, a viewport is that window, which through it you look at the world. Okay, right now my viewport is really small. It's not big, but of course you cannot see it or you cannot feel it right now because everything is completely black here. But in order to correct it, I'm gonna say, okay, grab the 0, 0 point in my form, so my viewport will span from 0, 0, so from the first point origin in my form until the width and the height of the form. So I'm gonna have here width and height. In fact, it's gonna be my OpenGL control, not the form, but it is technically the same here. So which I'm gonna pass in which I'm gonna call from here. So this function is gonna be called from here. Okay. Next, we have to have a perspective projection. So whatever object goes away from me gets smaller, and whatever object gets nearer to me gets bigger. So in order to do that, I have to talk to the projection matrix, which is responsible for distorting how the view is actually being distorted. Okay, so gl.gl matrix mode. So first of all, I have to tell OpenGL which matrix I'm going to work with. So gl_projection and gl.gl load identity. So I'm resetting my projection matrix, and in here I'm gonna just say glu dot. By the way, GLU is easier. I can use the same GL frustum, but it's much easier to punch in the number, and it's gonna be the same. I mean, the same performance basically. So GLU perspective, because there's a gl.gl frustum. Okay, which is going to be the same thing, but you have to specify left, right planes, bottom and top planes, and z near and z far. So the near clip plane and the far clip plane. So in here, I'm going to specify just the field of view, and I'm going to put here like 45 degrees or something like that, yeah. And the aspect ratio is the width divided by height, but since it's double and our width is integer, so I'm gonna cast this real quick here. So double double width divided by the double height, and z near, so the near clip plane is going to be 0.1 for me, and the far clip plane is going to be, let's say, 1000. Now whatever you're going to render, please make sure it's inside this volume. So do not put any do not position any object beyond the 1000, because you will not see it. Okay, it will just simply disappear from the scene, from your scene. Okay. Now another one is glu, in fact, .glu lookat. Now we don't have a camera. Technically, there's no camera in OpenGL. I mean, it is faked. You can call it like so. So basically, in order to look at things, they provided us some sort of camera transformation system, where you can where you can position where your eye is gonna be and where you are looking at. Okay, so this is your position of your eye. Imagine that your head is your camera and you have your eye, so basically positioning your head will define where the camera or where your head is positioned, and the centers here are telling where you are looking at, and the up vector is specifying how you are positioned in the world. Is y is pointing up, is x is up for you, or is z is the upward direction for you. Basically we always use the y. Okay, so basically I'm gonna put the position of the so-called camera, we can call it like that for now, in away a little bit. So we're gonna put it like in 3 in z. Please look at the origin of my system, and x is not my up vector. In fact, y is the up, how I look above. I mean, what is like the up vector with like what is above you, so we are elevating in y axis, and this is it. And after I finish all this, I have to return back to the matrix, model view matrix, so we ensure 100% that the user will not touch or play with the projection matrix unless he wanted to. If you want to play with it, just come here and play with it. So GL, or go inside the application and specify so. So gl.gl matrix mode, gl.gl underscore model view, and gl.gl load identity, and this is it. Okay, so basically, let me put some comments here. So this is what we can call like viewport is the window to our world, technically speaking. Projection. By the way, I'm not using here very scientific kind of definitions because it's easier to type right away. Of course, in OpenGL, Super Bibles, programming guides, and other books, they really describe it really scientifically with a nice, really big definition. So, projection matrix is the matrix responsible for distorting how our scene is being distorted. Okay, and this is the frustum / perspective projection. Okay, we can there you go, perspective projection is much better like that. Okay, this is for not for both of them. Okay, this is for this one, and I've already explained in the Maya lesson what is the perspective or perspective projection and what is the orthographic projection. Okay, so basically this is the perspective projection. Okay, backspace. Now there are a couple switches I would like to enable in OpenGL, because OpenGL is still a state machine. So there are some sort of imagine like a huge machine, and you are actually flipping switches in there. So basically, first of all, I'm gonna enable depth testing, gl underscore depth underscore test, and GL. Oh no, I believe I'm gonna clear the color here as well. So GL.GL clear color, and here I'm forcing the screen to be black in case, and put the alpha for 1. In case that you would like to make the screen like white or gray, you can just simply put it here instead of the black screen, which you usually have. Enable the depth testing for now, I believe, yeah, and the GL shading model, so shade model, I'm gonna call here GL.GL underscore smooth, and I will just keep it that way. I will not even go further. So basically here I'm specifying or telling the OpenGL application to smooth shading, to use the smooth shading technique in order for our polygons to appear nicer in our screen. You can put it flat shaded, you can put it smooth shaded, and so on and so forth. Okay, so basically if I hit Control F5 right now, oh no, hang on a second. Okay, so basically before we call the functions, this is what happens. So let us right now call the functions which we have set. So the first thing, we're gonna call this correct view, and it is gonna be after initializing the context. Please do not call it here or call it before the initializing context, because it will not work at all. Okay, so put it gl.gl gl settings dot correct view, and I will actually pass to it this OpenGL control dot width and this OpenGL control dot height. If I pass it the coordinates of the form is actually having a border over here, if you can see. Of course, as you can see here, my triangle has been rendered correctly according to my aspect ratio, but if I pass it my form coordinates end somewhere at these corners, while my control coordinates, this OpenGL control, end somewhere here at these corners. Okay, so that's why if I give it the OpenGL window, basically I will lose part of my view in this area, in this banner. So for this like header. Okay, so in order to make it correct, I'm gonna pass in the OpenGL control coordinates. This is the first thing. A second thing, GL settings dot set attributes. Okay, so basically we enable the depth buffer, we enable all these stuff. Now, one more thing we haven't fixed yet. So basically, if you look at it, our OpenGL application is rendered nicely, but once we start modifying our view, nothing happens up to normal. So in order to fix that, Control S, I am going to handle the event, so Shift F7 I believe, to go back to the view over here, to designer view, F4 for the properties of the control, and I'm going here for the event called size changed, double click, and when the window starts changing its size, please call this function, so please correct your view again, and then Control F5. And let's give it a try. So as you can see here, it works perfectly. So basically, if you are a 4:3 aspect ratio, something like some sort of window like with this dimensions, then you see, as you can see here, my triangle rendered correctly. If I have a wide screen like this, as you can see here, my triangle is still rendered correctly. It's not stretched out or something like that. So basically, this is how we can draw a simple triangle and set up our OpenGL application in a way that it works fine and project things normally. Okay, so I will actually, in the next lesson, I'm going to show you a couple tricks and a couple stuff that you can do, how to draw certain things, how to move objects in your scene, and then we're just gonna carry on from there. So I'm gonna stop right here. In the next lesson, we're gonna see how to color our triangle, how to color even each vertex, see the effect of that, probably even change the colors on the fly using the code, or I mean in real time. Okay, so see you in the next lesson.